Hello everyone, welcome to another video from the AI Loop. Today we're going to be looking at precision. It's a classification metric, and let's start the video. So before getting into precision, I must start off by saying why do we actually use precision? Well, in the start, if you're someone new to classification problem, you might have leaned towards accuracy. It's another metric that's used in the classification domain. It basically tells us how many are actually correct out of the total number of predictions that are there. So in this case, we can see that accuracy, as you go deeper into understanding the models and trying to figure out what's actually wrong with the models or where is it performing poorly, you would understand that accuracy is not intuitive or does not really help you understand how the model is performing on certain class. Now this is where precision kicks in. What precision does is that it helps us understand how well our model is able to, or how confidently is our model able to classify a certain class. And that's what we're going to be looking at. But before that, let's start off by understanding two things. Well, the first one is that remember that if we have a multi-class classification problem or even a binary classification problem, and let's say we want to predict 1 out of 3 classes, precision is a metric where we calculate it separately for each of the class. That's the way it's done, and this is how we get an intuition of how our model is performing on each of the class. And this is the first point. The second point is basically it's just a minor terminology brush up where we want to understand the terminology that's really helpful in understanding the formula itself. For this, I'll be drawing a table here. Let's consider one part to be a prediction and the other part to be a ground truth. And let's have 4 things here: true positive, true negative, false positive, and false negative. So let's understand this in terms of class 1. Remember that we talked about how we calculate precision for each class separately. So let's say we're trying to calculate a precision for class 1. So you would start off like this. Basically, any output that is generated by the model can be classified into one of these classes. So true positive is, let's say our model predicts it to be of class 1 and it is actually of class 1. True negative is where our model predicts it to be not of class 1, it's actually not of class 1. False positive is our model says it belongs to class 1 but it does not belong to class 1. And false negative is like our model says it does not belong to class 1 but in actual it belongs to class 1. And these are 4 terms that you need to understand to calculate precision metric. Let's start by looking at the formula of the precision. So precision is calculated by true positive plus false positives. Now what does that mean? If you look at the denominator part, the true positive and false positive is basically all the instances where the model predicted this to be of class 1. And remember that since we're looking at this in terms of class 1, everything in here in the denominator term sums up to the number of times when our model predicted all the things belong to class 1. And let's run through an example and try to understand precision here. So let's say I have a frame, right? And there are a bunch of fruits in there, and I basically give it to my model to predict either the number of apples and bananas in there. And I want to calculate the precision for apples, right? Let's see how we calculate it. But before that, let's define the ground truth data set itself. Now let's consider this to be our data. We have the prediction and we have the ground truth. I'm sorry for my ugly handwriting, but this A belongs to apple and B banana, obviously. So let's say our model predicted there to be 5 apples and 4 bananas. In actual, there are 2 apples and 4 bananas. So this is the data set, okay? This is the result that comes in after passing it into the model. Now let's calculate the precision for apples. So if we do the precision for apples, the formula is basically true positives by true positives plus false negatives. Now, what are true positives? True positives is an instance where our model predicts it to be an apple and it is actually an apple. Since remember, so look at it that we have two apples, so at the most there can be two apples present in the detection, right? Because the ground truth only consists of two apples, but our model predicted there to be five apples. So out of five apples, how many are actually positive? Two of them, right? Because there are only two apples that could be present in the frame. So the true positive becomes 2. And we repeat the same number here again. And true positive plus false negative, as I told, it corresponds to the total number of detections identified by the model. It's 5 here, so that basically becomes 3. Let's try to understand false negative here. Now, false negative is that we have two apples in the ground truth, right? And we totally predicted there to be 5 apples, and we know that out of 5, 2 of them are true positive. So the leftover is 3, so we know that 3 apples, our model basically took some other fruits and predicted them as apples, but in turn they're actually not apples. So it predicted three other fruits to be apples, and this in turn becomes 2 by 5. I honestly have no idea. Maybe it goes to 0.4. Now we can say that our model has a precision of 0.4. Now, what do you understand by a precision of 0.4? Remember that precision of 0.4 on apple class. Let's calculate the same for bananas, right? And I'll just start it from here. Like, what is the true positives in bananas? Well, there are 4 bananas. Like, the model predicted there to be 4 bananas, and there are actually 4 bananas. So the true positives become 4. And we repeat the same number again. And what is the false negative? Well, look at it that there are no predictions where our model predicts something to be a banana, but it is actually not a banana. So everything that it said to be a banana is actually a banana. I mean, that makes it really confusing when I say stuff like that, but I really hope you're following the point here. But yeah, we'll just go through the intuition to understand too. So here we have a precision of 1. And now let's try to understand how this works. So we have apple, we have bananas, and we have a precision of 0.4 for apples and a precision of 1 for bananas. And you have these results and you want to present your model to someone and you're explaining them. So the way this works is that for your model, whenever your model says, let's say you have a model here, and whenever your model says there are 10 bananas and 10 apples, the interpretation with the precision is that when it says there are 10 apples, you are so confident that you can say there are 4 apples out of 10, but you're not sure about the 6 of them, right? And when it says there are 10 bananas, you are sure that there are 10 bananas. And the way that we get these numbers is that, remember that the precision for banana is 1. So that's basically like you're 100% confident that every time your model claims something to be a banana, it is actually a banana. And for the case of apples, it's 0.4, right? So every time your model claims that something is an apple, you're only 40% confident that that particular object that it detected is actually an apple. So that's the way precision works. You can really model these into domain specific stuff. Like, let's say for some weird reason, detecting apples is so important to you. Not detecting the overall apples, but out of all the apples that are there, you cannot really misclassify apples. So like, you cannot really say that these apples are bananas or something like that. You really make sure that the precision for apples is high, so that's the way you model it into business specific use case. But that really depends on the domain or like the use case that you're working on, whether to prioritize precision or recall or both. So that's it regarding precision. I'll be making another video on the recall too soon. I really hope you found out the intuition behind how precision works and how it helps you understand the performance of the model on different classes. Please subscribe to AI Loop. I'll see you in the next video. Thank you for tuning in.